Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Nadira Shazana binti Abdul Isam, and today I will present on my research project with the title of Study of Thermal Comfort of Vehicle Heating, Ventilation and Air Conditioning HVAC System in terms of temperature and relative humidity of cabin. Air conditioner is a system of removing warm air and replacing it with cool air. And on the other hand, refrigeration is a process of heat transfer from the low temperature region to the high temperature region, and it is also called as reverse process of heat transfer, and therefore it requires refrigerator. So one of the examples of HVAC system is in its application in the transportation section. Automotive air conditioner, also known as AAC, is one of the applications. And AAC is very important in providing a comfortable environment inside the cabin with minimum energy consumption. What could possibly go wrong in HVAC system? Well, the major concerns of HVAC system is the energy consumption and thermal comfort. As for AAC, thermal comfort is very important, and therefore it is also crucial to identify the optimum conditions of a vehicle HVAC in order to provide effective thermal comfort inside the cabin for both the driver and also the passenger of the cabin. So from that, I have come up with two objectives of the study. The first one is to determine the effective thermal comfort of a vehicle HVAC system by comparing the temperature and relative humidity obtained from the variation of system inputs from the dashboard control. And the second one is to simulate the variation of system inputs from the dashboard control, as I mentioned before, by using a model from the MATLAB and Simulink. There are three methods that we use in the methodology of this study, which is the first one is experimental setup, the second one is simulation, and the third one is validation. So for the first part, the experimental setup, we use the Soltec AC01 air conditioning unit, in which this unit consists of two assembles, which is air conditioning system and also the refrigeration unit. And the experiment started with the set of blower change, which means different airflow from 15% opening to the 75% opening of the blower. And from this, the data that we collected is ambient temperature, which is 86, and also the refrigerant temperature. So from this data, we collect in order to calculate the relative humidity, and this relative humidity is used in order to plot the distributions of the temperature inside the psychrometric chart in order to determine whether if the temperature and the relative humidity is inside the human thermal comfort section. So the second part of the methodology of this study is simulation. For the simulation, we used a model available in MATLAB or Simulink with the title of Vehicle HVAC System. So for the simulation process, first we set the system inputs of the dashboard controls, which consists of heat dial from hot to cold, the fan dial from off to 4, the aircon switch, which consists of on and off switch, and also the recirculation switch also consists of on and off switch. So once we decided the system inputs that we're going to simulate, we start the simulation, and then we run for 2000 seconds of runtime, and we recorded the data, which is the data of cabin temperature and cabin relative humidity. So once the data is recorded, we can end the simulation, and then we can use the data that we have recorded before and put it inside and plot it in the psychrometric chart in order to determine whether if any of this data, when any of the temperature and relative humidity, belong inside the human thermal comfort, as we did with the experimental setup before. So the human thermal comfort section is at temperature of from 22 to 27 degrees Celsius and relative humidity of 40 to 60%. And now the last part of methodology of this study is the validation. So the model is validated by comparing the results obtained from these simulations to the results obtained from the experimental data. So from the experimental data that we obtained, the temperature and relative humidity that we obtained from the varying blower speeds from the experiment setup is compared to the temperature and relative humidity that we obtained from the simulation that we simulate with various system inputs from the dashboard control. So here are the results of the experimental setup and the simulations that I have conducted. So there are two simulations, which is simulation 1 and simulation 2. So for the first simulation, the system inputs manipulated is fan dial and also the recirculation switch. There are two inputs of recirculation switch, which is on and off, and these are simulated with the increasing fan dial from off to 4. So as you can see from the cyclomatic chart, none of the system inputs belong inside the human thermal comfort section. So therefore, we proceed with the simulation 2, in which the system inputs is the fan dial from off to 4, the recirculation switch is off, and also the heat dial of 0.2. So heat dial is function to control the humidity in the cabin. So the heat dial is set at 0.2 because any value higher or lower than 0.2 could result in higher or lower relative humidity, which can uh, deviates further from the human thermal comfort section. So as you can see from the cyclomatic chart, the human thermal comfort is achieved at the medium fan speed, which is at dial 2, which the temperature recorded is 22 degrees Celsius and the relative humidity recorded is 0.52. So based from these simulations, I can conclude that the higher the fan dial, the lower the cabin's temperature and the higher the relative humidity. So therefore, the fan dial of 1 or 2 is the optimum fan dial in achieving the comfort zone in a vehicle. And for the experimental setup, the experimental is carried in which airflow is manipulated from 15% to 75% blower opening. So from the cyclomatic chart, we can conclude that human thermal comfort is achieved starting at 60% blower opening. So these are the comparisons of the temperature and relative humidity obtained from experiment and simulation. So we can see that from the simulation, the temperature is decreasing as fan speed is increasing and the relative humidity is increasing with increasing fan speed. This is because increasing airflow will increase the temperature drop. However, as you can see, the temperature obtained in the experiment shows contrary as it decreased over increasing blower speed. This is due to the fact that the higher airflow gives large amount of water to condense at the surface of the coil, and therefore more heat transfer occurred in between the water condensed and the surface of the evaporator coil. And it is found that higher airflow will causes the higher bypass of the air and resulted in higher vent air and lower temperature drop. In conclusion, the results of the simulation shows that human thermal comfort is achieved at medium fan speed, which is dial 2, instead of the highest fan speed. And the cabin's temperature and relative humidity achieved is at 22 degrees Celsius and 53% respectively. And this is further validated by the experimental data in which the human thermal comfort can be achieved starting at 60% blower speed, which gives the temperature of 24 degrees Celsius and relative humidity of 55%. So the results obtained from both simulation and experimental prove that highest airflow does not give human thermal comfort, but it gives highest cooling factor and increase the power consumption instead. With that, thank you.